We knew some preliminary requirements right up front. We knew it was going to be on top of a tower. We knew we would have some installation challenges. We knew weight was at some point going to be an issue. We knew there was a desire for metal, there was a desire for light, there was a desire for a show and a spectacle. Beyond that, we then left it with the creative team to say, hey, here's aesthetically a dozen ways we could see accomplishing a flame. And it ranged everything from this to wild, unbuildable looking, smoking curls of flame. We just took all boundaries away right up front and let all of our best creative minds go at it. Once the creative minds had had a go, they took all those creative ideas and put it in front of us as a team. And each of us having kind of our own area where we're looking at this from, we pared it down to about 3 ideas, which we took a real quick stab in structurally at what the development of an execution for that idea would be. And from there, we again put it back to the team who commented on those 3 ideas. Each one kind of has their strength in terms of whether it's aesthetics, whether it's how many cool bells and whistles we could fit onto this thing. Engineering at this early stage is absolutely an invaluable part of what we do. It's also one of the key components that makes us different than others, is that we bring our engineers in early, because even though there's a whole lot left to figure out, we have a relationship we've built with our engineers where they understand the early stages. We can look at any version of this up front and we know a certain number of things. We know a size. We know up front, we have an idea about what a frame might look like in there. And even if it's wrong, we can sketch that in and it's gonna get us within 20, 30% of the likely weight. We know where it's at, what kind of loads it's gonna take. We know no matter how it's bolted down or whether that thing can take it or not, we know it's bolted down and it wants to do this. So the way we operate is that we isolate our piece and deal with it in a vacuum in early stages, assuming that everything else that touches it, we will figure out. Any flags or alerts, we will call out early. The way they're able to get in early is to work with us on ideation and concept. They're not writing down any specifications which are going to be stamped at this time. They're writing down what they think they're probably going to write on the specification based on quick math, so that I can start pricing the right tube, so that we can start getting within a ballpark of complexity. Already we figured out that regardless the method we go with, we're probably looking at 200 to 300 linear foot of tube that's probably 8 inches in diameter. We're probably around 1/2 to 3/8 wall thick. We know that what the shape is, more or less. We know how big a thing fits on a truck, so we know we have to break it in 2 pieces. The engineers are working with us and commenting on what that connection looks like. While knowing nothing, we actually can know about 50% of what's coming, with assumptions, with caveats, with a lot of context that we as professionals place around it to be able to have this conversation. The hope is that this team we've got going, who are all highly experienced in this, the processes that we've come up with, which a lot of them we implemented specifically for this project, these processes are going to allow us to use the expertise of our staff and our team to make smart, likely decisions forward. And we've all had a lot of talks, and we have it almost weekly. We're not going to get this right. There's no right, there's no correct, there's no perfect. We are going to get this completed in a smart way with premium detailing and the highest of craft. And there's a dozen ways towards it. So we're trying to just crunch down the context, slim up our boundaries, and kind of tighten the parameters as we move forward, until at the very last, in hopes, we're gonna put this thing up, we're gonna have no issue with the install, and we're gonna have a 0 punch list.
You cannot go near a project like this using only traditional fabrication techniques. You can't. The geometry is too complex, the coordination is too complex, the manufacturing processes are too complex. So it is the backbone of producing a sculpture like this. We need to have digital infrastructure and we need to have digital equipment in order to do it. By modeling the project digitally and leveraging digital fabrication, our client has essentially already seen the product. So we've had the client in the VR space, we've coordinated with them digitally, we've been able to make changes to the model directly on screen. So it allows them really to see the product before it's built. The 2 key investments are the digital infrastructure, so the SolidWorks workflow, the PDM workflow within SolidWorks, the digital front-end infrastructure for our CAM system, so everything that drives our manufacturing equipment, and then the manufacturing equipment itself. So all of our equipment here is top of the line and receives that digital information seamlessly. This sculpture is entirely made from steel, so all of our steel sheet goods are inside our manufacturing software. We can take all the parts, we lay them out on the sheet, we know how they fit on the sheet, we know how the machine will interact with the sheet, we know how it's going to cut, we know the path it will take, we know the number of passes that that tool is going to take across the material, so all of it is done ahead of time. So the digital fabrication team, they do all of that within the system. So if we take the water jet, for example, it runs a high pressure bead of water through steel, so that's how it cuts. It's got water mixed with aggregate, and that's how we get our cutting. That tool, the speed and the path are programmed into the software so that the operators can pre-run that path within the software so that we can see exactly how long the cut will take, the variance, if there is any, between the head and the material. Built into the part files are all the tolerances necessary for manufacturing. So if it is a break form piece of stainless steel sheet, for instance, the radius in which that is bent, the size of the cuts, the tabs, the naming convention that's etched into the parts, all of that is built into our files, so wherever it's produced it would be identical. The VR process in this has been key. So we've had a VR setup on the client side, so the client is able to immerse themselves in VR. They can see the sculpture, they can talk about details. Our designers here can immerse themselves in VR. We can actually be in the space at the same time as the client, which has been huge, so we can point to details, we can talk about connections. All of the changes are made in that space. It's actually a part of our workflow, so if changes are made to the master model we'll use for fabrication, those are updated in VR on a daily basis. It's also critical for the shop. So if I am a metal worker here at ASTOUND and I want to understand this project that I'm about to build, I can put on the VR setup. I can go in there and I can take a look, and it's a great part of the process for all of our shop employees to be able to be a part of the VR space, the digital space, and they get a lot out of it.
This is unreal. They're flying in so quickly.
Clearly, the challenge was the timeline, for sure. I mean, but the digital fabrication helped us out with that hugely. This has not been done before. There's only one of these, truly. And so anytime that you set out to do something that no one else has done, you can't reference any precedent. That's a unique challenge. Every decision that we had to make, which were abundant, I feel like we made all the right decisions. Every day I found things that I would do differently, but that's the nature of this business, and that's the nature of custom architectural fabrication, is that every project is a new chapter and a new experience where you learn little lessons, but they're not always directly applicable to the next project because they continue to be more and more unique and more uniquely challenging. The entire project was within a 1/16 of an inch of tolerance. There was very little tolerance just based on the unique challenges that Clark County imposes on structural features such as this. It needs to be able to withstand up to 105 mile-per-hour winds within a certain deflection. So with tolerances that are that tight is the only way that we could achieve that specification. Well, we always knew that it was critical that the pieces would have a calculated center of gravity. It was critical based on how they aligned to one another at the seam in between the three pieces of each flame. So we knew that they needed to lift totally level. At every single turn and at every different level of that assembly, different layer, the center of the gravity shifted. So we had designed these specialty lifting rigs that had calculated the center of gravity so that it would lift perfectly. It was so satisfying to see it almost like hover across the ground. It looked like a little toy, being lifted into place. There's a number of different project managers that are working on this project when it comes to the electricians, the iron workers, the team that was actually doing the crane work. So everyone had the same project plan, which is the same Gantt that we were all referencing, and everyone was always here exactly when we needed them with all the information that they needed as well. It's definitely the easiest install that I've ever worked on in my career, which is a huge achievement, I think, because of the scale and the complexity of the piece. But the fact that we were able to install that project in 6 days, 2 of which were called because of wind, is amazing. This project definitely sets a new precedent for number of people that you have to coordinate in order to make sure that all the details are truly satisfied. Whether it was the 7 different engineers that we worked with on this project, 5 different consultants when it came to fire suppression, or low voltage integration, or building code requirements, or work safety. I could actually probably fill a bus with the number of people that represented the brains that went into making this satisfy and check all the boxes. And involving those people when we did and how we did paid off, because when we installed it and the inspectors came, it was just good to go. When you work on a project like this, it's multidisciplinary. There's so many different people and so many different inputs that you need to consider, and we did all of that over Zoom. Everyone was in a unique corner of the world on a computer screen, and we were able to do this all talking over each other, sharing a screen, passing a sketch, and I've never done anything like that before. This would have been done in boardrooms for hours and hours and hours, and we were able to just completely shift gears almost seamlessly, which is another amazing benefit of digital fabrication. We were able to do this with only a few mock-ups and just doing things in 3D space.